Welcome to another episode of AI Squabble. Today we have a showdown where four large language models will battle it out in the game of Robocode. Robocode is a well-known programming game where players compete by writing code to control robot tanks in a fierce battle. The objective is simple: be the best and destroy the rest. Each tank is equipped with a body, a gun, and a radar to detect other tanks. Every hit drains energy from the tank, and when the energy reaches zero, the tank is destroyed. Firing bullets and hitting walls also reduce energy, but to a lesser extent than being hit by an enemy. When you create a new robot in Robocode, you're given boilerplate code for its default behavior. This includes responses for detecting enemies, getting hit by bullets, and colliding with walls. Let's see how these AI models use their coding skills to dominate the battlefield. For this squabble, I asked ChatGPT, Copilot, Gemini, and Mistral to provide code for four specific routines. They were motivated with the prompt displayed on your screen. However, keep in mind this is a one-shot experiment, and there are numerous ways to refine this test. The focus of this video is on the initial performance of these models, rather than a thorough investigation of their full potential. Let's see how each language model fared in generating the code and how their tanks performed in the competition. First up, ChatGPT-4 responded with a complete Java program. I was pleasantly surprised when I copied the code into the editor, and it compiled immediately without any issues. This was quick and easy. Copilot, on the other hand, wasn't as successful. Initially, it returned some empty functions, leaving me to fill in the content. When I asked Copilot to provide the function content, it generated some code but omitted the content for two helper functions, normalize bearing and reverse direction. When I prompted for those, it produced additional code but again referred to other missing helper functions. Eventually, I hit the conversation limit. So I decided to compile the available code, leaving the incomplete functions empty to highlight Copilot's shortcomings. Gemini's code also didn't work straight away. It used a non-existent function, and when I pointed this out, it initially provided code without enough context. When I asked for the complete function, it returned code with spelling mistakes, a static variable declaration inside a function, and a command requiring the robot to be derived from the class rateControlRobot instead of advanced robot. I decided to fix these issues in the code without further interactions with Gemini. Mistral's code also didn't work out of the box because it used a math function that doesn't exist. However, when I asked Mistral to fix this, it provided an alternative function, which allowed me to compile the code. Upon examining the code, it became clear that all procedures were not very complex and were quite similar to each other. I assume the models largely referred to their training data when generating code without specific requirements. However, no two functions were identical between the LLMs, so let's see how these differences impact the battles. Alright, I've added all four robots to the arena and set up 100 rounds. Let's see what happens. It's quickly apparent that ChatGPT-4's tank is dominating the game. The tank moves around more, changes direction frequently, and overall seems better at avoiding detection by the other tanks. Okay, let's watch one more round. Alright, let's speed up the battles to see which tank performs best. After 100 games, ChatGPT-4's tank won 99 times, and Copilot's tank could win one single round. As I mentioned, this was a one-shot experiment, and there are many ways to improve the code generation of the LLMs for this context. For example, you could ask the GPTs to specifically improve single methods of their code, and maybe in the future I will try that as well. Let me know if you have other ideas on how to use the GPTs in order to generate code for Robocode. Nevertheless, I hope you found this experiment interesting and inspiring. Thanks for watching, and I see you in the next episode.